Hello everyone, welcome back. Very soon Biovisit Tournament 5.0 is going to be conducted on 26 July 6 p.m. to 7:30 p.m. and it's an exciting opportunity for you to test out your coding skills and knowledge and win exciting prizes. So basically this contest is exclusively for school students, and in this contest you need to solve 2 coding questions, 200 marks, and 20 quiz questions, 100 marks. The total duration of this test is 90 minutes. So guys, do not miss out this amazing opportunity and do register now. Now let's move forward for today's session, in which we would be practicing some questions that would be helpful for you for the upcoming Biovisit Tournament 5.0. Okay, so let's start. Here is the first question. Which of the following sorting algorithms can be used to sort a random linked list? Okay, so we have a random linked list in the minimum time complexity. So we need to sort a random linked list in minimum time complexity, and the options are insertion sort, quick sort, heap sort, and merge sort. So it's a very easy question. So basically you need to tell which of them would be the best one, okay, to sort a random linked list. And the answer for this is merge sort, okay. So the answer for this question is merge sort. I hope the question is clear to you. Now let's move forward. 1 minute. Okay, next question is, which of the following standard algorithms is not a greedy algorithm? Okay, so we have some standard algorithms, and we need to tell which of them are not a greedy algorithm. That means they do not follow a greedy approach. Options are Dijkastra, Prince, Kruskal, Bellman-Ford shortest path algorithm. So the correct answer for this question is Bellman-Ford algorithm. Why? Because this is the algorithm that does not use a greedy approach. I hope the question is clear to you. Now let's move forward. 1 minute. Okay. Next question is, the worst case, the number of comparisons needed to search a singly linked list. Okay, so we have a singly linked list and the length of the linked list is n. Okay. Now we need to tell which is the worst case scenario, basically worst case time complexity, to find the element in the given linked list. Now basically the length of the given linked list is n, right? And we need to tell the worst time complexity, right? Now the worst time complexity could be that we need to traverse the entire list to find the element that we needed, right? So basically we need to traverse the entire length. Now according to this rule, the worst time complexity would be big O of n. Why? Because we needed to traverse the entire length to find out the element. So that is why the correct answer is big O of n. I hope the question and the answer is clear to you. Now let's move forward. 1 minute. Okay, the data structure required for breadth first traversal on a graph is, okay. So we need to tell which data structure is required for BFS, okay, on a graph. The options are stack, array, queue, and tree, and the correct answer for this is queue. Okay, so I hope this is clear to you. Now let's move forward. 1 minute. Okay, next question is, a queue follows. Okay, so we need to tell which kind of approach does a queue follows. The option is FIFO, first in first out, LIFO, last in first out, ordered array, and the last one is linear tree. So basically queue is kind of this, a pipe kind of structure, and if I'm pushing elements from this end, that means I am popping elements from this end. Okay, so basically if I pushed 5, then 5 would be the first element to pop out from here. So according to this concept, queue follows the principle of FIFO. First in, whichever elements come first, it is the element to pop out first. That means it is the first element to go out. So that is why queue follows FIFO, first in, first out principle. I hope this is clear to you. Now let's move forward. 1 minute. Okay. Now the next question is, what is the space complexity for deleting a linked list? Okay, so basically in this question, students can get confused. Deleting linked list. So maybe they are saying, delete a node on the linked list. No, in the question it is very clear that, you are deleting the entire linked list. Okay. Now when you are deleting the entire linked list in one go, not the nodes, entire linked list in one go, then the time complexity is big O of 1. Okay, so I hope the question and the concept is clear to you. Now let's move forward. 1 minute. Okay, next question. How many stacks are required for reversing a word algorithm? Okay, so basically we need to print the reversal of a given word. Let's take an example. Okay, the word given to us is A, B, C. Okay, now if I enter this in a stack, okay, so first A, then B, then C, right? Now basically a stack follows the concept of LIFO. That means last in, first out. Okay, so a stack follows the concept of LIFO. Now according to this concept, whenever I would pop an element out, first C would come, then B would come, and then A would come. So the output would be C, B, A. Now basically this is the reverse of the original one, right? This is the reverse of the original one. So basically, because the stack follows the concept of last in, first out, so basically we only require one stack to print the reversal of a word. Okay, so the answer for this question is 1. Okay, so I hope this is clear to you. If you guys are clear with the basic concepts, you can easily solve the questions. Okay, now let's move forward to the next question. Okay, now here is the next question. Let's read it. What will be the output if the following sequence of operations are executed? Okay, and the operations are here. See, basically, let's take an example. This is a stack. Okay, now in the stack, first I am pushing A. Okay, then I am pushing B. Okay, then I am popping B. Okay, so that means B is out. Then I am again pushing C. Okay, now there is no B, only A and C. They are asking me what would be the output. Now in the output, I can only display the elements which have been popped out, right? So basically, you can clearly see only one element has been popped out till now, right? The stack still has elements, but we are not popping those elements. They are stored in the stack. The only element which can be considered an output is the element which has been popped. So according to that concept, the answer for this question is B. Okay, because that is the only element that can be considered a output right now. I hope the question is clear to you. Now let's move forward. Okay, next question is, what is the complexity of adding an element to the heap? Okay, so we have a heap and we need to tell what is the complexity for adding an element in the given heap. Okay, the options are big O of log n, big O of h, big O of log n and log h, O log n. Okay, so basically the correct answer for it is big O of log n and big O of h. So I hope this is clear to you. Both are the time complexities whenever we are trying to add an element in the heap. Now let's move forward. Okay, 1 minute. Okay, now the next question is, if several elements are competing for the same bucket in a hash table, okay, many elements are competing for the same bucket in a hash table, what is it called? Okay, so basically we have a bucket and many elements are competing to come in it, like enter it. Now basically when many elements are trying to enter the same thing, they would collide with each other, right? For example, A would collide with B, B would collide with C, they would be colliding, right? So basically according to this concept, the correct answer is collision. Okay, because when they are fighting for their space, they would be colliding with each other. That is why the answer for this question is collision. Okay, I hope this is clear to you. Now let's move forward. Okay, so guys, I hope this session was helpful for you, where we practice some questions that would be helpful for you for the upcoming Biovisit tournament. And I hope you guys have enjoyed the session. If you guys have enjoyed the session, make sure you click on the like button and subscribe our channel. And guys, make sure you register for Biovisit tournament 5.0, which is on 26th July, 6 PM to 7:30 PM. And thank you so much everyone for joining me today. Thank you.